All right. For problem number 4, we're told that Markin decides to join a cross-country team in high school and that the graph will show data or information about his running. A key thing to recognize on this graph is that this is going to be comparing two variables. It's comparing how long he's been running in minutes, the time running, and the purple line's telling us as he starts running over time how much distance he covers in meters. We see it's a straight line that starts at the origin, so we know his running speed is staying constant if we see this straight line. Part A asks us, Markin will compete in a 12,000 meter race. It's a key piece of information, 12,000 meters. So you see on my whiteboard over here, we have that 12,000 meters written down in advance, and they want to know how many minutes it would take him to complete the race. To know how many minutes it would take him to complete the race, we need to figure out something about his speed, how far he goes every minute. And to help us, the graph gives us data. If I follow the purple line, the first time that it hits the corner of a grid box is right here at this data point where my mouse is. At 10 minutes in, we see 10 minutes in right here on the whiteboard, we have 2,500 meters that have been covered. As we keep going, it also hits this corner of a grid box here, so that's why you also see at 20 minutes, at the 20-minute mark, we've gone 5,000 meters. So that's helpful data to see. If I want to know how fast Markin's going, I can take one of those data points. So we'll take the 2,500 meters in 10 minutes. And if I do 2,500 meters, that's my y change, how far he went. And it took him 10 minutes to do that. I know when I divide by 10, that's just going to knock off 1 0 there, and we get 250. And specifically, that's going to be 250 meters for every 1 minute. If you did 5,000 divided by 20, you'd see the same unit rate, the same speed of 250 meters every 1 minute. So how long would it take 12,000 meters to happen if I do 250 meters every 1 minute? We need to set up a division problem. 12,000 divided by that speed of 250 meters per minute would tell us how many minutes we end up needing to get there. So if I do 12,000 divided by 250, would figure out 12,000 divided by 250 gives us 48. So it would take Markin 48 minutes to get there. So again, once we found the speed, that was the key piece of information, the unit rate. It would take him 48 minutes to go 12,000 meters. Part B asks us to write an equation that could be used to determine the distance Markin runs in meters based on the time running in minutes. And this key piece of information, 250 meters every 1 minute, is going to help us find the answer to that second part. We know his distance, and we'll put this whiteboard in full screen now. We know his distance, y, is going to be equal to his speed, 250 meters per minute, times x. However many minutes he runs for, if you multiply by a speed of 250 meters for every 1 minute, that will tell you y, the distance that he's run in total during that time. So again, our equation would end up being y equals 250 times x. And you may see this y equals kx is what Mr. Neville would have said last year. We'll start calling this a y equals mx equation, which we see every time the graph is proportional.